The Explorer tests have been voyaging through the universe for more than 45 years, and we can't help but wonder what will actually happen to these two tests in the far-off future. Will they truly come to a distant star system and potentially encounter extraterrestrials there? And where are NASA's Trailblazer tests, which were also launched during the 1970s? Explorer 1 and 2 were launched in 1977 to make use of a special alignment of the outer planets, Jupiter, Saturn, Uranus, and Neptune. They were essentially related and were as easy to reach as they are to visit once every few decades. NASA quickly put together two tests that have since made world history. Explorer 1 and 2 first ventured out to Jupiter and Saturn as part of their unique mission, with Explorer 2 additionally investigating Uranus and Neptune for the first time. Researchers shot tests through the planetary system in record time as part of supposed gravity assist moves. Only a couple of years after launch, the two tests gave photographs and scientific discoveries of Jupiter and Saturn for the first time. Explorer 1 communicated the first high-resolution pictures of Jupiter's trademark, the Great Red Spot, and recognized that it's a storm. The test found active volcanoes on Jupiter's moon Io and recorded the intricate ring systems and moons of Saturn. Explorer 2 continued its journey and became the first test to examine Uranus and Neptune up close. It captured the massive ice giant Neptune and discovered new moons and rings around Uranus. Explorer 1 was now on its journey to the outer reaches of the solar system, powered by a plutonium-238 radioisotope thermoelectric generator. The test has now flown over 24 billion kilometers into open space. Explorer 2 followed at a closer distance and is now also flying through the interstellar medium. Both tests are still sending data about particles, cosmic radiation, and magnetic fields daily. After more than 45 years of movement, their energy sources are gradually depleting, and NASA has been struggling with a few glitches from the space veterans lately. So far, NASA engineers have repeatedly managed to get the two explorers up and running again. The specialists have managed distant support at unbelievable distances, and if everything goes well, we can expect measurement data from the interstellar medium for the rest of the decade. But what will happen after the last radio contact with Explorer 1 and 2 when the batteries have finally given out? The Ghost Explorer 1 and 2 will still be flying, but they will not be able to send more data to Earth. Estimates have shown that in around 40,000 years, Explorer 1 will pass by the region of the star G445. By then, it will have traveled a distance of 17.6 light-years. Explorer 2 will pass near the bright star Sirius in 296,000 years. Neither of the tests has a direct destination. Rather, they are floating more or less erratically through the universe. They might fly for billions of years, and no one knows when or if the tests will ever be found by anyone. If they fall into the hands of an extraterrestrial civilization, the two tests have a valuable record on board. In fact, the plates are not completely made of gold, but rather gold-plated copper plates. They contain sound recordings of greetings from humans in various languages, as well as pictures, sounds, and music from Earth. So, when their mission reaches its conclusion, Explorer 1 and 2 won't just be decommissioned scientific instruments, they will be social diplomats, carrying humanity's heritage into the vastness of space. Where are Trailblazer 10 and Trailblazer 11? Trailblazer 10 and 11 are often forgotten amidst all the excitement surrounding Explorer, but these two are still out there in space too. Trailblazer 10 and 11 were two of the first probes to explore the solar system. Trailblazer 10 was launched on March 2, 1972, and Trailblazer 11 followed on April 6, 1973. The primary objective of both was to explore Jupiter and Saturn, after which they were to continue into the outer reaches of the solar system. In addition to their visits to the two gas giants, both missions were also designed to study how interplanetary space behaves at vast distances. Trailblazer 10 was the first probe to successfully cross the asteroid belt between Mars and Jupiter, paving the way for Explorer 1 in December 1973. It passed Jupiter at a distance of about 132,000 kilometers. Trailblazer 10 sent back the first close-up pictures of the gas giant and information about Jupiter's radiation, its strong magnetic field, and its violent environment. After that, it continued its journey into interstellar space. Sadly, the probe was no longer able to record the transition from the solar system to interstellar space. In January 2003, Trailblazer 10 transmitted data about cosmic radiation and the solar wind for the last time. Today, it is traveling a distance of about 130 astronomical units, or roughly 19.5 billion kilometers, from Earth, heading towards the constellation of Taurus. Trailblazer 11 also studied Jupiter and, in December 1974, provided unique data from the inner radiation belt of the gas giant. To do this, the researchers performed a risky maneuver, bringing the probe close to Jupiter, a feat that Trailblazer 11 survived in one piece. Jupiter's radiation is among the most extreme in the solar system. After successfully completing this mission, it sent back more detailed pictures of the ring system and discovered 2 new moons. Shortly thereafter, it continued on to Saturn, where the probe also studied Saturn's magnetic field and provided the first measurements of the temperature of its moon Titan. After its mission to Saturn, Trailblazer 11 continued its journey in the direction of interstellar space. Communication was lost in November 1995 when the power supply became too weak. Today, Trailblazer 11 is likely about 103 astronomical units from Earth, which corresponds to about 15.4 billion kilometers. In many millennia, Trailblazer 11 will likely reach a star system in the constellation of Lyra. Like the explorers, the Trailblazer probes also carry friendly messages for potential contact with extraterrestrial species. Each carries a gold-plated aluminum plate in its cargo. The so-called Trailblazer plaques are schematic representations of humans, Earth, and the location of our solar system in the Milky Way. The Trailblazers were the first probes to report back from the outer reaches of the solar system, followed by the Explorer twins. After that, there was silence for a while as NASA focused on exploring other destinations until New Horizons was launched in 2006. New Horizons, a mission to Pluto and beyond, became one of NASA's most ambitious space projects. Launched on January 19, 2006, the spacecraft was one of the fastest rockets ever launched from Cape Canaveral, and its primary mission was to explore Pluto, then considered the 10th planet from the Sun. New Horizons was also tasked with investigating Pluto's moons and objects in the Kuiper Belt, and its mission was part of NASA's New Frontiers program to gather new scientific knowledge about the still largely unexplored outer regions of the solar system. New Horizons was the first spacecraft to explore Pluto up close, providing the first real images of the dwarf planet. All previous pictures had been artistic depictions or somewhat blurry images taken by the Hubble Space Telescope. The first real encounter with Pluto was a historic moment in space exploration. After a 9-year journey, New Horizons arrived at Pluto on July 14, 2015. To achieve this record time, NASA engineers used a gravity-assist flyby at Jupiter in 2007. The spacecraft used a flyby and interaction with Jupiter's magnetic field to speed up quickly, reaching several thousand kilometers per second. What many people don't know is that New Horizons never entered Pluto's orbit. The spacecraft simply flew by, and the flyby lasted just a few days, providing breathtaking images of Pluto's complex surface, images of vast glaciers, ice fields, and potentially cryovolcanic features. Scientists had expected to find a barren world of rock and ice on Pluto, but Pluto revealed not only its famous heart-shaped region but also a surprisingly dynamic surface. The mountains on the planet are not made of rock but of ice, which is harder than rock on Earth. Cryovolcanism and dynamic ice fields led scientists to suspect that Pluto, like the icy moons Europa and Enceladus, could be warm inside and possibly even harbor underground seas with primitive forms of life. New Horizons found that Pluto's atmosphere is thin and consists of nitrogen, methane, and carbon monoxide. The spacecraft also observed complex weather patterns on Pluto, with cycles of liquid and gas, likely occasionally snowing thick layers of nitrogen ice onto the planet's surface. After this once-in-a-lifetime mission, New Horizons sent back astonishing data from Charon, Pluto's largest moon. Contrary to previous assumptions, Charon could be another small planet, not just a moon like its companion Pluto. This moon showed many geographical features, deep canyons, and smooth fields, prompting scientists to want to study the Pluto system even further, but we'll have to wait. New Horizons couldn't wait at Charon and Pluto, and the planned course took the spacecraft further into the Kuiper Belt. This region, beyond Neptune and Pluto, is a vast area containing rocky bodies and is home to some minor planets. On January 1, 2019, New Horizons successfully flew by a curious Kuiper Belt object, sparking the exceptional interest of scientists. The weird shape of 2 connected bodies provides scientists with significant clues about the processes that lead to the merging of objects, and this information could also explain how deformed small planets like Makemake or Haumea were formed. Now, do you also want to know where New Horizons is today? The spacecraft is located around 8.2 billion kilometers from Earth, which is about 55 astronomical units, where 1 astronomical unit is the average distance between Earth and the Sun. New Horizons continues to move toward interstellar space. However, it will be many years before it even comes close to the heliospheric boundary. New Horizons likely still has enough energy to transmit scientific data until the 2040s, when the spacecraft's power source, a radioisotope generator, will be depleted. This spacecraft will continue to travel quietly through the universe as a testament to our civilization. Subscribe now. We regularly publish exciting new videos on space and astrophysics research.